Imagine you are trying to build a house. You've got your blueprints, your lumber, a dedicated crew, and your trusty tape measure.
Sounds like a solid start.
Right. But there is a catch. This specific tape measure magically changes its length every single time you pull it out.
Oh, wow. Okay.
Yeah. 1 minute, an inch is exactly an inch. The next minute, that same inch is suddenly like 2 inches long. Sometimes it stretches, sometimes it shrinks.
That is a terrible tool.
It is. But imagine you and your crew rely on that tool all day, every day. How long until the foundation cracks, the walls fail to meet, and the entire roof just collapses?
Well, I mean, you wouldn't even get past the framing. The entire structure would be fundamentally compromised before you even notice something was wrong.
Exactly. Welcome to the deep dive. It is Thursday, March 19th, 2026, and today we're looking at the digital equivalent of that broken tape measure.
It's a great analogy for what we're covering today.
Thanks. We are exploring the hidden, somewhat chaotic, and honestly incredibly expensive world of data integrity. We're unpacking a stack of sources today from Validfor, specifically insights from their CEO, Omer Simon.
Yeah, his breakdown of this is just fascinating.
It really is. Because in our highly digital landscape, you and I constantly rely on dashboards, reports, and, automated metrics. We base our entire workdays, our investments, our strategies on them.
But we rarely stop to ask what happens when the underlying information feeding those beautiful, colorful dashboards is just fundamentally wrong.
Right. Okay, let's unpack this. Because is operating a business with bad data really like trying to build a house using that broken tape measure?
It absolutely is. I mean, it is a terrifying thought when you really sit with it. We have been conditioned to treat digital information as absolute mathematical truth.
Yeah, if a number is on a screen, we just assume it's right.
Exactly. But the reality operating behind those screens is often incredibly messy. When we talk about a data integrity problem, and this is a foundational definition from the Validfor's research, we are talking about a very simple concept. It's when information doesn't match reality.
It sounds so trivial when you put it like that. It sounds like a typo, like, oh, someone misspelled a customer's street name, or there's a mismatched timestamp between two software systems.
Right, it sounds like an administrative annoyance, just a minor glitch.
Yeah, exactly.
But these are not minor inconveniences. Much like your magical tape measure, these errors compound. A tiny deviation at the foundation level, say, a product weight entered as kilograms instead of pounds, turns into a massive structural failure by the time that data flows to the shipping department.
And then into the accounting software.
Yes. And finally, lands on the CFO's desk as a quarterly expense report.
And to understand how to fix that broken tape measure, we first have to look at just how much damage it can cause if you keep using it. Because we're talking about massive real-world stakes here.
The scale of the damage is wild.
It really is. When you look at the research from Validfor and the Harvard Business Review, the numbers are absolutely staggering. Bad data costs the U.S. economy $3 trillion per year.
That is just, wow.
$3 trillion with a T.
It is a number so large, it almost loses its meaning. Human brains really struggle to comprehend $3 trillion.
Yeah, it's just too big.
But it helps to realize that this money doesn't vanish all at once in some grand cinematic heist. It bleeds out in a million tiny cuts across thousands of businesses every single day.
Break that down for us. How does a typo actually translate to a trillion-dollar economic drain?
Think about the day-to-day operations of a standard mid-sized company. It's the supply chain manager ordering like 10,000 redundant units of inventory because a faulty dashboard failed to register that those exact units are already sitting in a warehouse in Ohio.
Oh, right. So you just bought stuff you already own.
Exactly. Or it's the marketing team spending $50,000 on digital ads targeting a list of leads that actually unsubscribed 3 years ago, but the system never updated.
Just literally burning money.
Completely.
Yeah.
And it's a logistics company paying massive overweight fines for their trucks because the database had the wrong pallet weights. Every single one of those errors burns capital, wastes human labor, and slows down the economy.
That makes the abstract number incredibly concrete. And you see this friction constantly when different departments are operating in their own little bubbles. Take the classic example of conflicting dashboards.
Oh, this happens all the time.
Right. Imagine you've got the sales team looking at their analytics tool, and they see a 12% conversion rate for the quarter. They are thrilled.
Popping champagne.
Exactly.
Yeah.
Meanwhile, the marketing team pulls up their specific software platform, and their dashboard shows a 15% conversion rate. Both teams completely trust their own numbers.
Because why wouldn't they? The screen says it's true.
Right. So they go into a cross-departmental meeting, and instead of actually strategizing, they spend the entire hour arguing over whose math is right.
And while they are arguing, they are misallocating thousands of dollars in ad spend because they are operating in two entirely different realities.
It's crazy.
What's fascinating here is that this happens because of silos. Marketing bought a tool that defines a lead one way, and sales bought a CRM that defines a lead another way. The systems don't talk, so the realities split.
And it's not just distinct software systems lying to us. The moment humans try to manually bridge those disconnected systems, the data corruption just accelerates. I am thinking of the classic spreadsheet merge mayhem from the techs.
Oh, the manual Excel dump. It is the absolute bane of modern business.
It really is. Because the systems don't natively talk to each other, a team member will just export everything to a CSV file to combine it manually.
Which is a disaster waiting to happen.
Say a marketing coordinator is trying to merge lead lists from 3 different global regions. Region A writes their days month, day, year. Region B does day, month, year. Region C uses an entirely different naming convention for their columns.
It's a mess.
Yeah, when you mash those together, a date like 04/05/2026 is read as April 5th by one system and May 4th by another. The result is hundreds of lost customer records, corrupted timelines, and totally derailed campaigns.
And if human error and silos weren't enough, you also have catastrophic technical failures. Consider the major cloud provider outage that happened in July 2024.
Oh, that was huge.
Right. This wasn't a typo. This was an infrastructural collapse that wiped out pending orders in real time. Businesses that did not have recent independent backups lost entire days of transactional data.
It was just gone. Poof.
Instantly. Information stopped matching reality, and companies had no way to know what they had sold, who they had sold it to, or where it was supposed to ship.
It's wild to think how fragile the whole ecosystem is. But wait, I have to challenge this whole premise.
Sure, go for it.
If the stakes are a $3 trillion loss to the economy, why do companies still rely on these incredibly fragile spreadsheet merge methods? If we know manually dumping data into Excel causes millions in losses, why are we still doing it?
It's a really fair question. And the root cause isn't just human clumsiness or laziness. It is the combination of those decentralized silos we just mentioned, paired with incredibly stubborn legacy systems.
Like really old databases.
Yeah. Think about a bank or a massive retail chain that has been operating since the 1990s. A lot of their foundational older databases simply lack modern validation rules. They will let invalid, incomplete, or totally nonsensical data slip right through the cracks.
So it just sits there.
Exactly. That bad data just sits there quietly in the server, only surfacing weeks or months later as mysterious gaps in the quarterly reports. And because replacing those legacy systems is seen as too expensive or risky, employees are forced to keep using manual spreadsheets as a duct tape bridge between the old tech and the new tech.
So it's like having a state-of-the-art high-tech security camera on the front door, but leaving all the ground floor windows wide open with no screens. You can see the problem, but you aren't actually stopping anything from getting inside.
That is a perfect way to put it. And trying to fix that bad data after it's already circulating in your reports is overwhelmingly expensive and time-consuming. You are paying highly skilled data scientists to basically act as digital janitors.
Right. Which naturally forces us to ask, how do we stop the bad data from entering the system in the first place? How do we close those windows?
Preventing errors at the source has to be cheaper than fixing them later.
And from what the research shows, that starts with strict entry controls. We are talking about data validation at the very point of entry.
Right. It's about creating an environment where bad data is mathematically rejected before it can even be saved.
So if an employee or a customer tries to enter a birth date that doesn't exist, like February 30th, the system actively rejects it.
It just bounces back.
Yeah, or if they enter a customer ID that is missing a digit, it bounces back. It also means using standardized templates. You force people to use drop-down menus and calendar pickers instead of letting them free type whatever they want into a mandatory text field.
That standardization is crucial. It drastically reduces manual typos simply by removing the opportunity to make them.
It makes me think of bowling with the bumper lanes up. You know when you're a kid learning to bowl?
Oh, yeah.
If the system simply won't accept an invalid entry, you literally cannot throw the ball into the gutter. The bumpers keep the data rolling straight down the lane toward the pins, no matter how terribly you threw it.
That is a perfect way to visualize the point of entry, but the bumpers are just the basic frontline controls. Modern engineering teams go much deeper into the underlying architecture to catch systemic problems early.
What do they use?
They use a tactic called test-driven development, or TDD.
Okay, unpack TDD for me. How does that actually work in practice?
So normally, developers build a new software feature, and then they test it afterward to see if it works. Test-driven development flips that completely upside down.
Oh, really?
Yeah, before a developer writes a single line of actual feature code, they write an automated test. They define exactly what the correct output should look like.
Give me an example.
For example, if I input a price of $10 and a tax rate of 10%, the output must be $11. Once that test is written, then they build the feature. If the feature's underlying logic ever corrupts the data and spits out $12 instead, the test fails immediately.
That's super smart.
They're essentially testing the plumbing to make sure no logic errors will corrupt the water supply once the main valve gets turned on.
So they test the system's ability to handle the data precisely before any real data is ever at risk.
Exactly. And they pair that with another crucial mechanism called continuous integration.
Let me guess, more automated testing.
Yes, but at a macro scale. In a large company, you might have 50 developers changing code at the same time. Whenever any developer attempts to merge their new code into the main system, automated scripts instantly run to validate sample data flows across the entire platform.
Wow, okay.
If a test fails or if a validation deviation occurs, the entire pipeline halts. Nobody can push that code live to the public until the issue is fixed. It acts as an automatic emergency brake for the whole company.
So, to stick with our bowling analogy, continuous integration is like a machine that rolls a mechanical test ball down the lane every single time a mechanic tweaks the bumpers.
Yeah, that's exactly it.
It does this just to mathematically prove the ball still reaches the pins perfectly before you allow any actual paying customers to use the lane.
That is brilliantly put. It ensures that an update to the scoring system doesn't accidentally remove the bumpers.
Right.
But even with all these safeguards, you still have to prepare for when things go catastrophically wrong, like that July 2024 cloud outage.
Right. How do you prepare for the cloud just disappearing?
Through disaster recovery drills, elite teams regularly simulate worst-case scenarios. They will intentionally trigger a simulated database corruption, pretend they've been hit by a ransomware attack, or simulate a complete hardware loss.
Just break things on purpose.
Exactly. Then they practice restoring their systems from backups. They do this to prove under fire that they can restore data integrity even under extreme pressure.
Yeah.
And there's a massive financial imperative for this proactive defense.
Because breaches are expensive.
Unbelievably expensive. In 2023 alone, the average cost of a single data breach hit $4.45 million. That's a 2.3% increase from 2022.
Over $4 million for a single breach. Wow. Okay, so we have bumples on the bowling lane for entry, we have emergency brakes on the code pipeline, and we have disaster drills for the worst-case scenarios. All of these guardrails require very specific tools to function. The industry has actually built an entire tech stack just for maintaining this day-to-day.
And it is an impressive arsenal of tools.
Let's look at how they function. First, you have data governance platforms like Validfor, which act as the central command center for setting all these rules.
Right.
Then you have validation frameworks. The open source library Cerberus for Python is a great example from the text.
Yeah, Cerberus is fascinating because it allows developers to define a schema, a blueprint of what a valid document should look like.
Wow.
Every time a database update is attempted, Cerberus checks the new data against the blueprint. If it doesn't match, it blocks the update.
Simple but effective.
Exactly.
Then you have backup and versioning systems like Veeam or native cloud snapshots, which are basically taking constant photographs of your data so you can rewind time if something gets corrupted.
Those are lifesavers.
And finally, you have data observability platforms like Monte Carlo and Big Eye. Wait, how does an observability platform actually catch a problem before it hits my report? What is it physically looking for?
It is looking at the metadata and the historical behavior of your system. It doesn't necessarily read the contents of every single customer file, but it monitors the vital signs.
Okay, make that real for me.
Let's say your central database usually updates with exactly 10,000 new rows of information every night at midnight. But tonight, it only updated with 10 rows. An observability platform flags that anomaly instantly.
Oh, I see.
It notices the volume is wrong, or the data isn't fresh, or the column formatting changed unexpectedly. It alerts the engineering team immediately, long before the CEO opens a blank dashboard at 8 a.m.
It's like a heart monitor for your server. If the pulse drops, the alarms go off.
Precisely. If we connect this to the bigger picture, though, Throwing software at the problem is never enough. You can buy Validfor, you can install Monte Carlo, you can run Cerberus, but technology alone is entirely useless without a human culture that actually values accuracy.
That is an interesting pivot, because as we discuss all these tools, I keep wondering if we are just trying to use algorithms to fix fundamental human carelessness.
You absolutely need both.
Yeah.
You cannot automate away human apathy. Culturally, an organization needs clear, documented policies. You need publicly available naming conventions so every single employee knows the rules of the road.
Makes sense.
But more importantly, the research highlights the need for defined stewardship roles. This means specific people called data stewards actually own specific domains of information. Someone owns the customer data. Someone else owns the product data.
What does a data steward actually do on a random Tuesday, though? Are they just fixing typos all day? I have to push back on this concept. Doesn't assigning a data steward just make everyone else in the company incredibly lazy? If I am a sales rep and I know it's the steward's job to fix the database, why should I care if I rush through my data entry and make mistakes?
That is a very common, very dangerous trap that companies fall into. If the steward is treated like a janitor whose only job is cleaning up everyone else's mess, the entire system fails.
Because they just get overwhelmed.
Exactly. The volume of bad data will eventually drown them. That is why the frameworks from Validfor heavily emphasize regular, company-wide training and a psychological concept called celebrating wins.
Celebrating wins, like throwing a party because a spreadsheet finally merged correctly.
Sort of, yeah. It's about changing the psychological incentive. You have to cultivate an environment where staff can report errors without fear of punishment.
So they aren't scared to say, I messed up.
Exactly. Finding a mistake shouldn't be a source of shame. Early detection is a win. And you publicly celebrate those milestones. You announce to the whole company, our team fixed 500 bad customer records this quarter. Or, we hit 100% backup uptime during the disaster drill.
Well, that's clever.
By making it visible and positive, you reinforce that caring for data is a collective habit. It's everyone's responsibility. The data steward is the guide, setting the standards and running the training. They're not the maid cleaning up after the party.
That changes the mindset completely. It shifts the culture from, oof, I have to do this for compliance, to look at how reliable and sharp we are making our foundation.
Right.
But if human culture and our current tech stack represent the present reality, the sheer unimaginable scale of modern data means we are going to need serious help handling the load in the future. The research points to some emerging trends that promise to make data integrity prevention exponentially smarter.
Yes, the landscape is shifting rapidly to keep up with the volume. The first major trend is AI-powered validation.
Okay, AI. Always a buzzword, but how does it help here?
Well, earlier we talked about rigid rules. The bumpers on the bowling lane. For example, rejecting a date that falls outside a specific window. But machine learning models can go much further. They detect subtle, complex shifts in data patterns that rigid, human-written rules might completely miss.
Give me an example of how AI validation differs from a rigid rule.
A rigid rule says, do not accept a transaction over $10,000. But an AI model looks at the historical behavior of a specific vendor. It might notice that vendor A always submits invoices on Tuesdays for roughly $2,000.
Okay.
Suddenly, vendor A submits an invoice on a Friday for $9,500. A rigid rule lets that pass because it's under 10 grand.
But the AI says, wait a minute.
Exactly. The AI flags it as highly anomalous based on behavioral patterns. And because it's AI, the system actually gets more accurate over time as it learns what normal looks like for your specific business.
So it's like moving from a security guard who just checks ID badges at the door to a security guard who recognizes everyone's face, knows what time they usually arrive, knows exactly how they usually behave, and flags someone just for acting nervous.
That is a brilliant way to put it. It moves from static defense to dynamic observation. Then you have the integration of blockchain.
Blockchain? I feel like most people only associate blockchain with cryptocurrency.
They do, but in the context of data integrity, it is being used for immutability.
Immutability meaning it cannot be changed or deleted.
Correct. Highly regulated industries like pharmaceuticals or global finance are exploring blockchain technology to create tamper-proof audit logs.
How does that work practically?
In a blockchain structure, every single record cryptographically links to the previous state. This means if someone tries to make an unauthorized change retroactively or alter a historical ledger, it breaks the mathematical chain.
So everyone sees it immediately.
Exactly. The tampering becomes immediately, undeniably obvious. You cannot quietly alter the history of a data set.
That would be massive for compliance audits. No more wondering who changed the spreadsheet 3 months ago.
Exactly.
And the third major trend the research mentions is data mesh and virtualization. Now, here's where it gets really interesting, because I have to stop here. This seems like a massive contradiction to everything we have discussed today.
How so?
Well, we spent the first half of this deep dive literally blaming silos for causing the $3 trillion problem.
We did?
We said that different departments owning their own disconnected data causes merge mayhem, conflicting realities, and arguing over dashboards.
Right.
But now, this massive future trend, data mesh, says that decentralizing ownership is the future. It says we should give individual teams ownership of their data products.
Wait, doesn't the data mesh contradict what we just said?
Yeah.
How is a mesh different from a silo? Aren't we just renaming the problem?
It's a brilliant question, and understanding the distinction is vital to understanding the future of data architecture.
Uh-huh.
A silo is decentralized, disconnected, and completely unmonitored.
It's the marketing department hoarding its own data in a dark room, making up its own formatting rules, and refusing to talk to sales.
Right.
A data mesh, on the other hand, gives teams ownership of their data to reduce the bottleneck of waiting on one central IT team to do all the work. But, and this is the critical difference, a data mesh maintains a unified governance layer.
A unified governance layer. Explain how that works in practice.
Think of the governance layer as a universal translator and rulebook that sits above all the departments. Marketing still owns their marketing data, and sales still owns their sales data. They process it themselves.
So they still have their own rooms.
Yes. But the mesh ensures they are both required to use the exact same formatting rules, the exact same validation checks, and the exact same definitions of reality before that data is allowed to interact with the rest of the company.
Ah, I see.
They're decentralized in their daily operations. They
Yep.
can move fast, but they are completely unified in their structural standards.
Okay, I get it now. A silo is everyone speaking a completely different language in separate locked rooms. A data mesh is everyone working in their own separate rooms, doing their own specific tasks, but the governance layer forces them all to speak the exact same language.
Yes, exactly.
So when they finally open the doors and need to collaborate, they can flawlessly communicate.
Precisely. It allows a massive global enterprise to scale its work infinitely without breaking the fundamental reality of the numbers.
So what does this all mean for you? If you are listening to this and thinking about your own company's dashboards, the core benefits of investing the time and capital into data integrity are immense. The research distills it down perfectly.
It really pays off in the long run.
Absolutely. First, you get better and faster decisions. You spend zero time arguing over whose numbers are right, and 100% of your time actually acting on the reality of the market.
Which is invaluable.
Second, you drastically lower your compliance risks, which is literally a life or death metric in strict industries like healthcare or finance. Third, you achieve massive cost savings. You stop contributing to that $3 trillion drain by eliminating the supply chain errors and the wasted marketing spend.
And ultimately, you enhance trust.
Yes. Your customers, your partners, and your investors know that what you say matches reality every single time.
And the most important takeaway to remember is that maintaining data integrity isn't a one-and-done project.
Right, you can't just buy a tool and forget about it.
Exactly. You don't just buy a governance platform, run one disaster drill, celebrate a win, and check a box forever. It is an ongoing daily journey. But it is a journey that turns a deeply frustrating operational challenge into an incredibly powerful strategic asset.
It really is about making sure the tape measure you use to build your business is always accurate, no matter who pulls it out of the toolbox.
Well said.
But I want to leave you with one final thought to mull over. As we move rapidly into this future, we just explored a future where AI becomes increasingly adept at quietly fixing our data errors in the background,
Right.
recognizing behavioral anomalies we can't even see, and automatically smoothing out the inconsistencies of our digital world. Will we eventually lose our human intuition for spotting when the reality of our business has fundamentally shifted?
Oh, that's a chilling thought.
Think about it. If the machine is always perfectly automatically fixing the map for us, do we eventually stop looking out the window to see the actual road?
We just might.
Thank you so much for joining us on this deep dive. Take a hard look at your dashboards tomorrow and keep questioning the reality behind the numbers.